Hello everybody, my name is Omar Guerra, and today, as a part of my solid state physics course, we're going to be making salt crystals. Now, what are the ingredients that we need? First of all, we need salt, because what are salt crystals without salt? Secondly, we need warm water, as this would help in the dissolving process of the salt. Thirdly, we need a heat-resistant glass, because in this experiment, we're going to be using an electric oven in order to heat up the water, as to speed up the evaporating process. So, I will be giving you all of the steps needed for you to make your own crystals at home. Moreover, we'll give you a detailed physics explanation as to why do salt form crystals. Stay tuned. So, opening this up, filling it up. So these are the crystals that we got from the glass cups. They look really nice. If you look them really up close, they form very cubic shapes. But why is that?
So, salt crystals. This process took about 4 days. We kept the water below boiling temperature, but hot enough so that it would evaporate as fast as possible. Without this heat, it would have taken anywhere between 2 to 3 weeks in Kuala Lumpur's very humid climate. So, as I said, in the interest of time, we utilize heat. This causes thermal vibrations that overcome the weak van der Waals force holding the water molecules. Water is a polar molecule due to its covalent structure. The negative oxygen side of the molecule attracts the positive sodium ions, and the positive on the hydrogen side attracts the negative chloride ions. This attraction is greater than the ionic bond, which effectively breaks it, and hence the salt dissolves. As water evaporates, less molecules remain to exert their polarity on the remaining ions. This means that as we reach the solubility limit, the free ions once again feel attracted to each other and make ionic bonds. So, the electrostatic energy. The long-range interaction between ions of a charge, Q, plus or minus, is the electrostatic interaction. They're governed by this equation, Q squared over R being the distance between them. The ions, they arrange themselves according to whatever structure gives the strongest attractive interaction compatible with a repulsive interaction at short distances between ion cores. You can see this little diagram here that shows that at different distances R, the interaction or potential energy increases or decreases, and it's optimal at R equals 236. So when the ionic bonds form again, the structure meeting the optimal conditions mentioned in the previous slide is known as a phase center cubic unit cell. In solid state physics, FCC, is formally defined as a cubic lattice with the phase positions fully equivalent to each of the 8 corners. Now, let's try to make sense of this by looking at the diagram on the right. The middle molecule, which is a purple molecule, in this case chlorine, at each phase, meaning top, bottom, left, and right, are all position equivalent to the 8 other purple molecules in all corners of this cube. Now, this is a natural arrangement process that occurs in crystals such as sodium chloride. It creates clear edges, the picture on the right, and half cubes attached to the glass, as you can see on the beautiful image on the left. This shows that our current understanding of the physical process that occurs in sodium chloride crystals takes effect in a simple experiment as just letting water evaporate from a glass inside an oven. Now, FCC is one of the most efficient way of packing atoms, and it will always create cubic structures. If we allow for bigger crystals, you will see that the structure becomes a little bit rectangular, but that just means that there are miniature cubes forming side by side along a straight line, straight plane. So now you know how the physics behind the arrangement of sodium chloride and exactly how to do it at the comfort of your home. So thank you for watching this video. Hope you're all well. Peace out.